Welcome to the Neuroscience Data Integration through Use of Digital Brain Atlases course. It's great to see that so many of you have attended already. This is the 5th iteration of the course. The second time we have it as a satellite to the Neuroinformatics Assembly of the ICF. And I'm really happy to see that the interest in the course is very broad. So just to start off by looking at who we are and where we are and when we are here, I think we can say good morning to most of you, good afternoon to some, and there might also be a few people, at least looking at the sign-up list from the United States, to whom we might say good night. But welcome everyone. Most of the participants signed up, I don't think everyone is in yet, are from Europe. We have people interested in clinical neuroscience. We have people working in experimental animal research, and we have also people signing up out of general interest. About 50% of the participants works somehow in relation to human brain neuroscience. And the rest in animal research. We have students in neuroscience, we have more experienced researchers, and also other participants who have different backgrounds and motivation to join. And experiences vary also a lot from people working with imaging methods, working with molecular biology, or microscope-based methods. So we have a diverse set of participants, and we really look forward to interact with all of you through these 2 days of interactive course. So in total, 42 have signed up to participate, but I expect that people will come and go a little bit as we move along. All right, so first, to give you a little background. So if we look at Atlas, Atlas is a Titan, the one who holds up the heavens, and this image of Atlas holding up the heavens is usually, or has traditionally been, put onto various maps, and therefore the name Atlas has been associated with maps. Maps and descriptions of the brain have existed for a long time, starting in ancient Egypt with descriptions, drawings in various ways, including drawings from Leonardo da Vinci. Vesalius's maps of the brain are, of course, a milestone. With the invention of the microscope and better optics and microtomes, it was possible to start looking into brain tissue with various types of microscopic methods and using different chemicals to both fix and stain tissues. And this has, of course, led to the field of cytoarchitectonics, which is relevant for some of the content we will touch upon today. Cytoarchitectonic boundaries and maps of such. And of course, navigation in the brain using stereotaxic coordinates is an important approach in many branches of neuroscience, building on different ways to measure position. And this is, of course, important in imaging studies. Also, in particular in humans with a tolerant coordinate system, but also in the rodent brain. The anatomy of the brain is something that is taught worldwide to medical students, looking at macroscopic sections, studying the organization of brain systems and pathways, which is important in medicine and for people in particular who want to be or who become neurologists. But of course, it's also an important part of neuroscience. So why do we then need a course on the neuroanatomy and Atlas-based data integration? Well, The first part of this relates to the abundance of neuroscience data. If you go to PubMed, there are increasing numbers of publications on all topics in neuroscience, and it's becoming more and more difficult to grasp and get an overview of what information is available on different parts of the brain, diseases affecting the brain, and where the research field is at the moment. So there is a need for data integration that has been recognized, and one way of achieving such integration is, of course, to relate data to a common anatomical context, and their locations in the brain are important. So the brain and neuroscience data are complex and challenging to deal with because of the complexity of the brain, with a large number of neurons, synapses, and axons bound together into this tiny volume, forming this machinery we call the brain. And then, of course, in order to integrate various types of measurements from the brain, anatomical context gives a common ground to which we can relate different measurements and data and observations. And in that way, we can also create ways to connect data, find data that are relevant, and work with them. So the course today will give you information about concepts for integrating research data using brain atlases. We will have a session today giving insight into approaches and resources for assigning anatomical location to brain data. This will also include introduction to brain anatomy and how to navigate in different parts of the brain. We will look into possibilities and limitations of current human and murine or rat mouse, or maybe also monkey, the digital brain atlasing resources that are provided through the eBrains infrastructure. And we will look at tools for spatially integrating different types of image data that come out of brain research studies. So, how will this be done? And let me then also start to introduce the people who will convey the information in this course. Probably forgot to mention that my name is Trygve Leergaard. I'm a professor of neuroanatomy at the University of Oslo. I will be starting and closing the course, but otherwise the content will be given by lecturers such as Jan Bjorli from the University of Oslo, from Nicola Palomero Gallagher, from Menno Witter and Timo Dickscheid today, who will give lectures. And along the way, we have a team of instructors and facilitators from the Neural Systems Laboratory here at the University of Oslo, with Ingvild Bjerke, Maya Pushades, Sharon Yates, and Harry Carey, who also will contribute to group discussions and in particular will also give the hands-on course that will happen tomorrow. If we take a quick look at what we will do, we'll have lectures, seminar style. We will try to encourage interactivity during those sessions, having discussions among you that we can have both in the plenary Zoom room here, and we will also, for several exercises, divide you into groups to go out to breakout rooms for more open discussions and practical problem solving on tasks that you will be given during the day, today and tomorrow. We will take that along the way. So if we take a quick look at the program, we will start today with a lecture by Jan Bjorli on concepts for sharing and integrating neuroscience research data. After the break, we will move on to work on how to navigate the human brain. And there, Nicola Palomero Gallagher from the Jülich Research Center will introduce you to basic concepts and give some practical insights into how you can define anatomical location in the human brain. Then after a lunch break, we will have Menno Witter from the Kavli Institute at NTNU in Norway, who will give us insights into how to navigate in the rodent brain with a particular focus on the anatomy of the hippocampus. And then later today, we will have an introduction to the eBrain's Digital Brain Atlas resources by Timo Dickscheid, also Research Center in Jülich, who will show and tell how digital three-dimensional brain atlases can be used today to both learn about brain anatomy and to get access to data and to connect information about the brain. So that's the first day. So today we will have a day with a focus on theoretical and practical approaches in neuroscience.